Welcome to our next session in transportation engineering. In this session, we are going to see the problems related to the transition curves and some more basic problems related to other topics also. Okay, you will be seeing this. So the first question, an expressway, 4-lane divided. Okay, so they have given 4 lanes passing through a flat terrain. So they have given a flat terrain, it's nothing but a plain topography. Okay, has a horizontal curve of radius equal to ruling minimum radius. Okay, so they have given the radius related to ruling minimum radius. I hope we have solved some problems in superelevation chapter to know how to determine this ruling minimum radius. And then they have given if the descent speed is 120 km per hour, so v is also given, and take rate of attainment of superelevation 1 in 150 means for every, I told you, 150 centimeter 1 centimeter rise. Okay, so they are asking you to calculate the following elements of the curve. The first question they are asking you to determine is radius, then superelevation, then extra widening, then they are asking you to calculate the length of the transition curve. Okay, so we'll go one by one. You see, the first they have given v is 120 km per hour, and the maximum allowable superelevation we know is 7%. Okay, 0.07, and friction is 0.15. Okay. So first thing we are going to find is the radius, ruling minimum radius. If you remember the formula, E plus F equal to V square by GR. I think you should have seen the superelevation session. We have derived this equation also. So you bring that R one side and then bring everything this side, V square by E plus F into G. So when you substitute 0.07 plus 0.15, we will have radius is equal to V square divided by 0.22 into G. So if you substitute instead of V, you substitute 0.27. Why you are substituting 0.27? I hope you should know 1 km per hour is equal to and 1000 meter divided by 3600 seconds. It is nothing but 5 by 18 meter per second, which is nothing but 0.27. So to convert kilometer per hour to meter per second, I have to multiply this 0.27. So the instead of V square, you can see in this formula V square, I used 0.27 in V square. Okay, so V is 120, I know, this is becomes capital V, 120 square divided by G is 9.81, E I know 7%, 0.15, which will give me the radius of 500, so this meter, 515 meter. Okay, so this is finding 1, we found the radius of this problem, particular problem. So if you see, instead of even solving, you should memorize this answer also. So for 120 km per hour, we are getting a radius in terms of 500 meter. Okay. The second finding, they are asking you to design the superelevation. So if you remember the design of superelevation, step 1, we have to ignore the friction, and we also has to take the, if you remember, we have to take the mixed traffic flow condition for the step 1. Okay. So we have to take only 75% of the design speed. Understood? So same formula, E plus F equal to V square by GR. I have to ignore the friction, and instead of V I have to take 0.75 V. So in that way I got this formula, and you can see 0.75 is for mixed traffic flow condition and 0.278 is for converting kilometer per hour. So V is given as 120, G 9.81, radius just now we found it is 515. Substitute everything, you will get 0.124, which is nothing but 12%. We cannot provide 12% as IRC is suggested. We cannot provide more than 7%. So we have to go for step 2, providing the superelevation of 0.07. You have to go for a step 2. In step 2, you see the friction is, we have to determine the friction. If you remember the step 2, I have to determine the friction required to maintain the ESI Emax. Okay, what is the friction required? Whether the friction required is less than 0.15, then you can provide ESI Emax, or you have to change the design speed by providing a E equal to Emax. Anyhow, E equal to Emax only. So you can even stop at this step. Anyhow, if you are getting answer more than 7%, anyhow you have to provide at least 7%. Okay, so you can see. So anyhow, coming back to the problem, you see friction, you substitute 0.278 into 120 divided by G minus 0.07. This is radius is 515. You do this algebra, I am getting 0.149, which is less than 0.15. So obviously it is safe with friction. So we are going to provide the maximum superelevation of 7%, 0.07. Okay. So third question they asked is to find the extra widening. If you remember extra widening, Formula NL square by 2R plus V by 9.5 into root R, where N is the number of lanes. In this question they have given 4 as a number of lanes. Most of the questions, if they didn't give you, IRC suggested value for length of the base is 6.1 meter. Okay, so you should memorize this number, 6.1 whole square divided by 2 into the radius we know 515 sub plus this formula V is in kilometer per hour. If you remember, I told you while deriving this extra overriding term. So you see this V is 120 divided by 9.5 into square root of R, square root of radius is 515. When you substitute everything, you will get the extra overriding term as it is in meter, 0.701 meter. So now we got everything. Fourth thing we have to find is length of the transition curve. So step 1 is to find the C value. You just substitute that 120, 80 by 75 plus V is the formula given by IRC. You substitute, you are getting 0.41. Step 2, if you remember the formula, LS1 was equal to V cube by CR. Instead of V, you have to just substitute 0.278. Like to convert to kilometer per hour to meter per second. So V cube by CR. You substitute all the values, 0.278 into 120 divided by radius 515 into 0.41, which will give you 175.6 meter. Okay, so step 3, it is LS2. I will assume it as a central line rotation. So if you remember the formula, E B by 2 into N. We know E just now in step in finding 3 we got E is 0.07. You can see B by 2 is just, you should know, it is nothing but total widening plus extra widening. If you remember, total widening for 4 lane road is 3.5 meter into 4. That's why I got 14 meter here. And extra widening, the previous finding we found it is 0.7. Adding both, you will get the B value and N, rate of attainment of super elevation. So that 150 is here. Okay, so it's very simple. You multiply, do the calculations here, you will get 77 meter. Step 4. I hope they have given the plane topography. It's 2.7 V square by R. V is given 120 and radius is 515. You do the algebra, so you will get 75 meter. Okay, so maximum of this 3 is 175 meter. So length of the transition curve, you have to provide 175 meter. So this solves this particular question. I hope it made you clear in the concept of super elevation. We also solved problem related to extra widening and also problem related to ruling radius and also related to the transition curve. Okay, so the next question, mostly, so how you did the previous questions, exactly the same procedure will be adopted. I have no other option, because I have the problem. If you want to find the length of the transition curve, obviously you have to do all the things. Okay, so find the length of the transition curve and extra width of the pavement. Okay, they are asking this one separately. Length of the transition curve required on a horizontal curve of radius 300 meter on a 2-lane highway passing through a rolling terrain. Okay, very good. And design speed is given. Assume all other data as per IRC recommendations. So some cases, if they didn't give you any details related to super elevation, okay, you can just do LS will be, you can just find these two and then take the maximum value also. And remember, as a trainer, I have to tell you this LS1 will be the most of the case, this one will be the answer. Okay, most of the case this will be the answer. Very rarely LS2 or LS3 will be greater. Okay, so anyhow, so you have to determine LS1 based on centrifugal acceleration, LS3 based on topography, provide the maximum value. So they have asked two questions. One is length of the transition curve, another one is extra width of the pavement. We will see one by one. So they have given radius, they have given number of lanes, it's 2, and they have given the design speed 80 km per hour. Okay, so we know step 1 determine C value, you got 0.51, very good. Step 2, I hope you know V cube by CR formula, so you just substitute everything, you are getting 71 meter, very good. And as I told you, they have given the rolling terrain. For rolling terrain, we know it is 2.7 V square by R. You substitute the V value 2.7 into 80 square by R. If you substitute everything, you will get 57.6 meter. So LS is maximum of LS1 and LS3. You provide this maximum value as a 71 meter. So the first part of question is over. The second part is you have to determine the extra widening. We know the formula for extra widening, LL square by 2R plus V by 9.5 into root R. Substituting all those values, N is number of lane is 2, length of the base is 6.1 and radius is 300, V is 80 and radius is 300. When you substitute everything, you will get 0.61 meter. Okay, so this is the answer for the second question. So this question will be a revision again. Okay, so going to the next question. You can pause the video and solve yourself and then come and verify for your answer. You can see the question 23. A national highway passes through a flat terrain. It is something like the question we solved 2 problems before. Horizontal curve of radius equal to ruling minimum radius. Okay, they have given the design speed 100 km/h. Okay, you see they are asking you to find side distance, also super elevation, extra widening and the length of the transition curve. If you solve this problem, you will able to solve all the theories whatever we have studied so far, and we have to assume the necessary data. Understood? So if you solve this problem, you will able to determine everything whatever you have solved so far, like how to do the side distance, super elevation, extra widening, everything. All the theory you have studied in last 4-5 sessions will be covered if you solve this problem. And they have given 100 km/h as a design speed. Okay, anyhow we will solve. So we know the design speed, and I hope from now you got experience to determine the minimum radius. Absolute minimum radius is determined 0.07 and f equal to 0.15, and we know the formula E plus f equal to v square by gr. So the radius will be equal to v square by g into E plus f. You substitute all the valid values, you will get this number 358 meter. Okay, step 2, there we have to find the side distance. If you remember the side distance formula, Vt plus v square by 2gf. If you convert this formula is in meter per second, so to convert into kilometer per hour, you have to something like this. Okay, 0.278 v whole square divided by, you can see instead of v I have written 0.27 v, that's it, 2gf. Okay, here plus or minus n percentage is there. In this problem there is no gradient, so just substitute. You have to substitute all the values. If you remember, v is given 100, t is given as a 2, you should know for stopping side distance it is 2.5 seconds, and then g is 9.81, and friction value you should know. You should know for 100 km/h it is approximately 0.35 less friction. And if you fill all the standard values, because if in question they have given IRC is asking you to assume the values, right? So if you substitute 0.27 into v into t plus all the standard values, you will get this 332 meter. Okay, you can pause the video and solve yourself. This question is a revision, so I am going little quick. Okay, you should know all these things already. Step 3, they are asking you to design the super elevation. So we know the procedure of super elevation. In step 1, you have to neglect the friction, and then we have to assume the mixed traffic flow condition. Substitute that mixed traffic flow condition divided by gr. Okay, so instead of v, to convert to km/h, meter per second, I have multiplied these numbers. You can see g 9.81, radius we got now 358 meter. Substitute everything, you need 12%, which is obviously greater than 7%, you cannot provide. So we need to check whether friction will be okay. So friction, I hope you know, v square by gr minus 0.07. You just substitute yourself and see the requirement was 0.1496, which is obviously less than 0.15. So providing E equal to 0.07 will satisfy everything. Okay, so answer for this question is 0.07. Extra widening, NL square by 2r plus v by 9.5 into root r. This was the fourth finding they asked you. 2 into 2 is the number of lanes, L is 6.1, radius is 358 meter, 100 divided by 358 meter is 0.6 meter. So adding 7 meter plus 0.66 will give you 7.66 meter. Okay, so the finally they asked you also to find the length of the transition curve. We know LS equal to VQ by CR, LS1. Okay, so you just substitute. First you have to find the C. For substituting 100, you will get 0.457. So V cube is 0.278 into 100 whole cube divided by radius is 358, 0.457 will give you 131.29 meter. And as per super elevation concept, you see this is LS2 and this is LS3. LS2 we are again assuming central line rotation. Most of the case it will be central line rotation, or you don't need to assume. Anyhow the answer will be more. I told you, right, LS1 will be the most of the time answer. You don't need to even do this. But anyhow, so you can determine. We got E 7%. Okay, we just decided in step 2 or finding 2, and total width also we have determined. Extra widening also we have determined as 7.66, and rate of attainment is 150. Okay, so you just substitute everything here, you will get 40 meter. And for flat terrain, you just substitute in this formula 2.7 v square by r will get 75 meter. So maximum of this 3 is 131 meter. So we have to provide this as the length of the transition curve. Okay. So I hope by solving this problem you understood again or like revised stopping side distance, extra widening, and also the length of the transition curve. Okay. So with this we are closing this session. I hope I made you clear how to solve the problems in length of the transition curve and other topics also. Okay. So anyhow, we will solve a separate session of solving question paper session after this the subject is over. In that we will solve more and more problems. Okay. So I will meet you in the next session for setback distance and curve resistance. Okay. Thank you.